Hello everyone, welcome back. This is Mr. Hussein Mwasapi. So in this video, we'll be looking at limits involving piecewise functions. So before we begin, don't forget to like and subscribe to the channel. Alright, so what you have to understand first is what a piecewise function is. Now, a piecewise function is just simply a function built from pieces of different functions over different intervals. I believe most of us have come across piecewise functions in different methods of math. But for those that haven't, you will get to understand what piecewise functions are. So, how can we understand this clearly? Say you have a limit as x approaches c of the function f of x. Say it's equal to L. Now, what you have to understand is this. If you have a piecewise function, then you'll have f of x being equal to two or more functions. For the sake of explanation purposes, I'll just use two functions. Say you have f of x, which is the first function, and this function is of the condition that x should be greater than c. Then you have another function f of x, which is of the condition that x should be less than c. So now, what you're having here is what we're calling the piecewise function. Now, there's some pointers you're supposed to know about piecewise functions. So let's get to it. So, if you have what we're looking at, the limit as f of x as x approaches c being equal to L, if you have two conditions, what you have to understand is this. For the left-hand side limit, you have to pick the function that has x being less than c. For the left-hand side, pick x being less than c. While for the right-hand side, pick a function that has x being greater than c. Then if you want to define the function, pick the point that has either less than or equal to, or just maybe the equal to sign, or greater than or equal to. Do not forget this important point. For the left, x should be less. For the right, x should be greater than what it is approaching. For the defined point, x should either be less than or equal to, or greater than or equal to the approach. Alright, so let's get to understand this with few examples. So, given that you have a function f of x, which has two functions, the first one is 3 minus x, and the other one is x over 2 plus 1. Now, each function has a condition. The first one says that x should be less than 2, and the other one says that x should be greater than what? 2. In our first question, we're being asked to find the limit as x approaches 2 from the positive side of the function f of x. So now, we need to pick the function where x is approaching 2 from the positive hand side. Now, what function is from the positive hand side? And the positive simply means the right hand side. So, we're going to get the function that is showing the positive side. So, what we'll do is this. We're going to say limit as x approaches 2 from the positive hand side. Now, what would be the function from the positive hand side? So, the function would be the second one here, because the condition is that x is greater than what? 2, which means the positive side. So, it's going to be limit as x approaches 2 from the positive hand side of x over 2 plus 1. Then all we have to do here is to evaluate. So, upon evaluating, all we do is just plug in. So, if we plug in, we have 2 over 2 plus 1. Here we know 2 over 2 is the same as 1 plus 1, and 1 plus 1 simply gives you what? 2. We do the same thing for numerator 2. We need to ask ourselves, the limit as x approaches 2 from the negative side, what function satisfies such a condition? So from the negative side, we're talking about the left-hand side. So the only function that talks about the left-hand side is the first function, because the condition that x is less than 2. So any number less than 2 is on the left hand side of the x or y plane. So this means that we're going to get the first one, which is simply 3 minus x. Then at this point, all we need to do is to substitute. Upon substituting, we'll be having 3 minus, substitute, we put for 2, we'll have 3 minus 2. So 3 minus 2, we know is going to give us what? 1. And we have found the limit in A. Now the question is, does a limit of f of x exist? Now, the limit of f of x is the one where x approaches what you have here, which is what? 2. So it's approaching 2 of the function f of x. So now, here it doesn't really specify to say it's from the left or the right hand side. We just want to know if the limit of the function exists. Now, for it to exist, we know that the limit as x approaches 2 from the positive hand side of f of x should equal to the limit as x approaches 2 from the left hand side of the function f of x. Now, if you remember, from the left hand side, we had what? From the left, we had 1. From the right, we had what? 2. So from the left, we're having 1. From the right, we're having what? 2. Now, 2 is not equal to 1. As a result, the limit does not what? Exist. So here we're going to say does not what? Exist. Which means that the limit as x approaches 2 from the positive hand side of f of x is not equal to the limit as x approaches 2 from the negative hand side of f of x. So that's why we said does not exist. Now, in this case, they might give you a trick question, but the concept is one and the same. So here we need to find the limit as x approaches 4 from the left hand side of f of x. So now the limit as x approaches 4 from the left hand side of the function f of x. So now, if you look at 4, if we're looking at 4, now which function gives you the left hand side of 4? Because here it's saying x is less than 2. X is less than what? 2. Now, when x is less than 2, we can't really derive the fact that as x approaches 4 from the negative hand side, it will be equivalent to such. Because if you look at the values that are less than 4, all those values that are less than 4 are greater than 2. So the function that we're going to get is the bottom function, which is x over 2. Because we want to pick the values that are on the left-hand side of 4. So the closest values that we can get. So the closest values we can get are numbers like 3 or 3.9, just like that. So if we can get the values that are less than 2, when the values that are just before 4 are values like 3. So we're going to get the bottom value, the bottom function, which is x over 2 plus 1. Then we plug in for our approach, which is 4 over 2 plus 1. 2 into 4, you get a 2 plus 1, that gives you what? 3. Now here we're saying that the limit as x approaches 4 from the positive hand side of the function. Now the positive hand side of the function, so if you look at the two functions you have, the positive hand side, it won't be x being less than 2. Because x being less than 2 is on the other side of the function. And these values that are just after 4 are values like 4.1 and 5 and beyond. But we need to consider the fact that we are having 2 in our conditions, but we're looking at the approach being 4. So we will not get x being less than 2, but we get x being greater than what? 2, which will be the limit as x approaches 4 in the positive hand side of x over 2 plus 1. If we substitute, we have 4 over 2 plus 1. 2 into 4, that's 2 plus 1, giving you what? 3. And that's what you will have. Now, the question is, does a limit of f of x exist as x approaches 4? Now remember, for it to exist, the limit of f of x as x approaches 4 from the positive should equal to the limit as x approaches 4 from the negative of the function f of x. Now, if you look this side, from the left you're having 3, and from the right you're also having what? 3. So you will say, yes, it exists. So, yes, it what? Exists. And that's your answer here. But they're saying, what is it? So, the limit, you say this implies that lim as x approaches 4 of f of x is simply equal to the common value you found, which is what? 3. So you put 3 as your final answer. Looking at the last example, say that you've been given that the f of x is equal to the first function x plus 3, as x being greater than or equal to negative 1, and the function negative x minus 1, having the condition that x should be greater than negative 1. So does a limit of f of x exist as x approaches negative 1? So for it to exist, lim of f of x as x approaches negative 1 from the positive should be equal to the lim as f of x as x approaches negative 1 from the negative. So all you have to do is just do up the data. We can check the lim of f of x as x approaches negative 1 from the positive. So from the positive hand side, we're looking at values that are greater than negative 1. So we can get x being less than 1. Okay, because if we get x being less than or equal to negative 1, then we're not looking at the values that are greater than negative 1, but we need to get x being greater than negative what? 1, because we're trying to look at the values where x is approaching negative 1 from the positive hand side. So it's function number 2. So we have lim as x approaches negative 1 in the positive hand side, so we get function number 2 minus x minus 1. Then we try to evaluate, so you have minus of minus 1 minus 1. Negative times negative, you get a positive, minus 1, in the end you get 0. Then you do the same thing for the other limit, say lim of f of x as x approaches negative 1 from the negative hand side. So try and look for values that are less than negative 1. So we're going to get a function where it says x being less than or equal to negative 1. So we're going to have lim as x approaches negative 1 from the negative side, which would be x plus 3 as our function. If we plug in, we'll have negative 1 plus 3, giving you negative 1 plus 3, and your answer being what? 2. So now, the limit as x approaches negative 1 from the negative is not really equal to the limit as x approaches negative 1 from the positive. So this is not satisfied. So you say, therefore, does not exist. So that's your final answer. Other questions that might come in, questions what we're saying, is the function defined? Now for you to know if the function is defined, you look for the condition that has less than or equal to, greater than or equal to, or just the equal to sign, of which between the two, it's the one on top. So I'm going to say f of x is equal to x plus what? 3. So we're trying to see if it's defined at f of negative what? 1. So we see f at negative 1. Is this defined? So it's a negative 1 plus 3. So f at negative 1, you get negative 1 plus 3, and f at negative 1, you end up getting what? 2. So it is defined at this point, and the value is simply just what? 2. So be mindful, these are the possible questions that you come across under limits. So remember, if you have questions, you can reach me on WhatsApp on the number that's attached to the screen or the number that's in my description. Do not forget to like and subscribe to this channel. My name is Mr. Hussein Wasab. Remember to strategize before you become a statistic. Let's try and push for that A+.